Hi and welcome back to another video where we get to talk about calculus. So today we're going to talk about derivatives of inverse functions. And what you need to understand is that when we say derivatives of inverse functions, we're meaning general terms here. So these are not defined functions. If you have the equation for a function, clearly you would find the derivative and evaluate the derivative using the function. This is an example of a problem that shows up on the AP exam where we don't know what the equations are and we're asked to demonstrate an understanding of the relationship between functions, their inverses, and their derivatives. So first of all, let me walk you through a couple of steps where if you take these steps every single time, you'll be successful in answering these questions no matter what. The first thing you need to do is understand that the problem is asking you to evaluate inverse functions. So it will oftentimes tell you that, a function and its inverse. It'll define it for you. So some of the notation you might see differently. It might say let f of x and g of x be inverses. It might just say that g of x equals f inverse of x. And what we need to understand is that when you have a function that's an inverse, the definition of an inverse is that the domain and the range have been exchanged. So when I tell you that like f of 2 equals 5, well, when we start dealing with the inverse functions, f inverse of 5 would equal 2. So the output for the original function becomes the input for the inverse and vice versa. So what we need to do first is we need to lay down the relationship and make some equivalent statements using our inverse function. So if f of 3 equals 6, if g is the inverse, the first thing we want to do is we want to put it in terms of the inverse function. We want to say g of 6 equals 3. So we always want to make that statement first where we define the numbers that are given to us in terms of the inverse. We want to swap the domain and the range in the inverse function. Now, I also will always, if the problem contains this f negative 1 notation, I will always redefine my function using a g of x. So one thing you want to get in the habit of doing is, especially on a free response type question, is you want to say let g of x equal the inverse. The reason why I say define everything in terms of g is because when you start having f prime, f inverse, and f inverse prime, there's a lot of f's floating around, and that little negative 1 in the notation can be easily confused for a derivative. So I would always prefer to use two different letters. So if your original problem comes in terms of f to the negative 1, just take a moment and write down and say, let g represent this inverse function. And you can redefine functions, and then we're just going to use the letter g throughout to avoid confusion. So then the problem usually will also give you information about the derivative. It'll say if f of 3 is 6, f prime of 3 is this value. So it does this in the next line. And then it asks you to find g prime. So it wants the inverse derivative. That's what g prime is. It's the inverse derivative. So before we can do this, we need to understand a relationship between f and g. If they're inverses, then we have this definition, f of g of x equals x. So what we're going to do now is we're going to differentiate this equation with respect to x. And when we do that, we're going to remember to use the chain rule. What I mean by that is this. When I do the derivative of this left side, it's going to be f prime of g of x times g prime of x. That's the outside-inside rule. And then the derivative of x is just 1. Now, our goal is to solve for g prime of something. So that's what we want to get alone. So what I'm going to do is I'm going to take and divide both sides by f prime of g of x, f prime of g of x. And so now I have this statement, g prime of x equals 1 over f prime of g of x. Okay, now I have my general statement. Now I'm ready to find g prime of 6. So if I want g prime of 6, well, that's just 1 over f prime of g of 6. Okay, so here's where it became really important to make that equivalent statement. So I'm going to zoom back out so we can see all the work that we've done so far. Right up here in the beginning I said, make that equivalent statement. Put the 6 and the 3 in terms of the inverse. The reason we did that is because now, oh look, g of 6 is 3. So if I continue writing this out, g prime of 6 is 1 over f prime of g of 6. Well, that's 3. And hey, looky there, f prime of 3 is given to us. You'll always be given every little piece of information you need. So f prime of 3 is 3/4. 1 over 3/4 is 4/3. So there's my answer. That's g prime of 6. So again, our steps are this. We always redefine anything involving f inverse using the letter g. We just make a little statement, let g be the inverse. Then we put everything, we take whatever given f of 3 is 6. We make some sort of equivalent statement using the inverse where we flip-flop the 6 and the 3. And then after that, we differentiate this relationship, f of g of x equals x. And once we differentiate that relationship, all the information we need to plug in and evaluate should already have been done if we're following these steps every time. So let's take a look at what this problem here looks like, and we're going to try it on your own. And as a matter of fact, if you want to pause this video and try it on your own, I highly encourage you to do so. Alright, so here we have our information. F of 2 is 5, f prime of 2 is negative 8. We want to find d dx of f inverse of 5. So the first thing I'm going to do is I'm going to say let f inverse of x be defined with the letter g of x. I always want to write that down. I don't want to assume that whoever's reading my paper is going to know and make that, that connection. So I always want to really well define things if I'm going to replace them or rename them. And then we're going to say g of 5 equals 2. So I'm going to take this information, flip-flop the domain and the range, and make that equivalent statement. Now I have everything I need. So we want to find g prime. So this would be find g prime of 5. So using our letter g instead of f inverse. So here we go. I'm always going to start f of g of x equals x. Chain rule says f prime of g of x times g prime of x equals 1. Solve for g prime. G prime of x equals 1 over f prime of g of x. Okay, that was easy. Now I want g prime of 5. So here we go. Let's plug it in. G prime of 5 equals 1 over f prime of g of 5. Boom, g of 5 is 2. That's why I make that statement. 1 over f prime of 2. And f prime of 2 should be given to me. So this is 1 over negative 8. Ta-da! There's my answer. So again, make sure you use g instead of f inverse so we don't have too many letter f's floating around in our problem. Always make a statement where you're flopping the inverse, the domain and the range, and then differentiate that f of g of x equals x statement. You do that every time, you're going to get these problems right. So keep at it, practice this anytime you can, and they do tend to show up on the AP exam. So this is a good problem to know and be familiar with. But keep going, keep working at it. You've got this.